calculate the pH of the following. First one is 1 times 10 to the minus second molar HCl. First thing to do is write out the equation. Since it's a strong acid, it's assumed to go directly to products, no equilibrium necessary. So now this becomes a very easy problem. If I have 1 times 10 to the minus second molar HCl, then I'm going to have 1 times 10 to the minus second of this and of this. But all I need is the H plus concentration, so I don't care about this one. So I'll have, if I have 1 times 10 to the minus second molar HCl, I'm going to have 1 times 10 to the minus second H plus. So since this is base 10, the pH is going to be 2. That was very simple. The next one is HCl as well. There's no difference there, it's just a different number. pH correct. And that is slide 5. In this case, the pH is a negative number. Let's round that up. Anytime the concentration is over 1.0, then we'll get a negative pH. And the last one is probably the only one worth actually doing. These other ones were kind of a little bit too easy, but strong acid and strong base problems are not hard at all. We'll do this one, NaOH. Not a G. It's going to go to completion as well. It's also 1-to-1, so this concentration of reactant will give me the same concentration of product since it's 1-to-1. But this is OH, so what I'm going to do, there are a couple of ways I can do this problem. I may as well do both. Since it's being dissolved in water, one thing that I can do is use the Kw. Since Kw is equal to 1.00 times 10 to the minus 14th, I believe. And I am correct. This is Kw. Kw is equal to the hydrogen ion concentrations and the hydroxide ion concentrations multiplied by each other equals this. So what I can do is say Kw over OH is equal to the hydrogen concentration, because in order to get the pH, I need the hydrogen concentration, not the hydroxide concentration. So one way of going about it is this way. I'll do the other way next. So I'll have what's it, 5? And that is equal to Now I take this and put it in the pH formula. That is equal to 12.7, call it. That's one way of getting it. Another way of getting it is to use this idea. So what I can do is get the pOH is equal to minus log. I don't know from there. Use the pOH, subtract it from 14 to get the pH. So we'll do it that way this time. Minus log. And this number, why am I getting the calculator out? It's going to be the same as this one over here. 2. No, it's not. Never mind, that's only 1. Never mind. Minus log. If I could just divide it, whatever. No, I can't divide it, it's a log. Cannot divide. What was I doing again? Oh yeah. 5 points. So this is equal to 1.30. So that's the pOH. What we were thinking of doing before, 14 is equal to pH plus pOH. 14 is equal to pH plus 1.30, and then I'll subtract. pH is equal to 12.7. Same answer.